So today's lesson is going to be dealing with if things are proportional or not, and we're going to do a combination of tables and graphs kind of combined together. So to begin today, we have a warm-up. Our warm-up for today asks us to determine if the graphs are proportional, and then we have to explain why or why not. So remember, when we're trying to determine if they're proportional graphs are straight lines that pass directly through the origin. So if we look at this first one, notice we do have a nice straight line, so we have that portion. However, it does not go through the origin. So this graph would be not proportional, and it's because it doesn't pass through the origin. Okay, so I did the first example. Your job is to pause the video and answer the next two graphs to determine if they are proportional and explain why or why not. So looking at the answers, the second graph is not proportional, and it's because the graph is not straight. And then our third graph is proportional, and it's because not only is it a straight line, but it's a straight line that passes through the origin. So let's start off with a slight review from earlier this week. The first question is this table proportional? Remember, when we find proportionality with tables, we have to find ratios, and ratios are always y divided by x. In tables, the first column is our x, the second is our y. So looking at this first row, if we find the ratio, it would be 7 over 1, which simplifies to 7. Our next ratio would be 14 over 2, which is 7. Going down, we have 21 over 3, which simplifies to 7. And last but not least, we have 28 over 4, which reduces to 7. In each case, our ratio was always 7. Because it was the same, our table is proportional. Now, because it's proportional, let's see if we can come up with the unit rate. What is their distance per hour? Well, we actually can see it right in our table. They go 7 in 1 hour. We could say 7 miles, 7 feet, 7 inches. We don't have a label, but it is 7 over 1, and that would be our unit rate. Notice we sometimes will call it a rate of change. Now, if we review from yesterday, what you need to do is you need to create a graph from the table and determine if it's proportional or not. So remember, we're going to graph all of these points on the grid. I like to think about the graphs when we graph them as ordered pairs. So 3 hours, 15 songs we can think of as 3:15. You go over 3 and up 15. Our next point is going to be at 6:30. 6 hours, and we listen to 30 songs. Our third point is at 9:45. And our last point is at 12:60. So I graphed all of my points. And then the next thing we're going to do is we're going to connect our dots. And we can kind of fill in where our line should go through because we can kind of see that on here, which is nice. And we actually get a nice straight line that goes right through the origin. So, because it's a straight line and through the origin, we know this is proportional. Now, because it's proportional, we have to find that rate of change or that unit rate. How many songs per 1 hour would they listen to? So we can take any of our ratios that we have. I'm going to use the smallest numbers. If we right now listen to 15 songs in 3 hours, how many songs would we listen to in 1 hour? Remember, it's division. 3 divided by 3 is going to give us 1. So we also should divide the top by 3. 15 divided by 3 is 5. So our unit rate is 5 songs per hour, and our graph is proportional. This one is a slightly different example than the last one. First, we're asked, is this graph proportional? So let's look at our graph. It's a nice straight line. It goes through the origin. So is it proportional? Yes. Yes, it's proportional. All right. Now what it's asking is we have to find our rate of change, or that unit rate. So, unit rate, we're trying to figure out how many, this is our x, and this is our y, how many plants per seed. So we're trying to find the number of plants for 1 seed packet. However, we don't see 1 seed packet on here. So we have to take points and calculate it. What we can do is we can make a table to help organize our points. So if I make a table, I see the point 0, 0. We also have the point 10, 20. And we have the point 20, 40. We have more points, but 3 is plenty. And we need to find a unit rate, or that rate of change. So why don't I use this pair right here? 20 over 10. If we have 20 plants for every 10 seed packets, how many plants will be for 1 seed packet? Well, 10 divided by 10 is 1, and 20 divided by 10 gets us our answer of 2 plants per seed packet. So not only did we determine the table was proportional, we also were able to find how many plants per seed packet. And last but not least, our particular brand of fruit cups has 70 calories in 1 serving, 210 calories in 3 servings, and 350 calories in 5 servings. We have to complete the table, determine if the relationship between the 2 quantities are proportional, and explain our reasoning. So let's first start with completing the table. Our table information is going to be pulled out of here. We have 70 calories in 1 serving. So if we have 1 serving, we can say we are going to have 70 calories. There are 210 calories in 3 servings. So we have 210 calories in 3 servings. And we know there's 350 calories in 5 servings. 350 calories in 5 servings. Now remember, in tables, this is our x, this is our y. So we can go ahead and graph these points on our table to figure out if our relationship is proportional. We could calculate it from the table, but sometimes it's easier just to look at the graph. So we have the point 170. 1 serving is 70 calories. And that's going to be a rough estimate, but that's okay. we have the point 3, 210. 3 to 10 is probably about right there. And we have the point 5, 350. 5, 350. Now if we draw a line connecting these 3 points, so our line when we draw it in is going to go like that. Now looking at this graph, can we tell if these quantities are proportional? We have a straight line that goes through the origin. So technically we should say yes, it's proportional. Now, not only do we have to determine if it's proportional, but we also have to explain why. We could go about explaining it using the graph. When we connected our dots, we had a straight line through the origin. Or you could use the table and find that ratio. Is 70 over 1 equal to 210 over 3, which is equal to 350 over 5? Well, if you divide them all every time, you get 70. So it's proportional because it has a constant rate of change. And remember, rate of change is our new way to say unit rate. They're the same types of things.